how many people are familiar with Lambda or just the term serverless in general? Okay, it's a fair amount. So I'm going to sort of give like 2 talks in one. So the first talk will be sort of like an overview of the landscape a bit. Who are the players in making your life with Lambda easier? And then the second part will be more of like a blueprint of how we do things at MetaMetrics to deploy apps with Lambda and API gateway and other things serverless. All right. All right, so again, my name is Jinwright. I'm also a senior software engineer at MetaMetrics, and like I said before, we're hiring. So what is serverless computing? And some gotchas in AWS serverless computing. Well, the first gotcha is there are servers. Wait. There we go. So the phrase serverless doesn't really mean that there's no servers. It just means you as a developer, or you as a systems engineer, or you as a guy working on a project on the weekend does not have to worry about it. This is sort of like an evolution of 2 different schools of thought. One being the PaaS, which is like the platform as a service, which Heroku and App Engine sort of championed back in the day, and another one which was functions as a service, which is really where this lineage is closer to. If anybody in here remembers PyCloud.com or has ever used Iron.io worker, you can understand this. And so some of the other gotchas from serverless on AWS is things like the 50 megabyte size limit, or not being able to pass more than one cookie at a time, or little things like that. But overall, you get 100% utilization. So Scott Miller can attest to this. We're running 3 production apps right now. Pretty popular, I guess, or with decent traffic. And our AWS Lambda bill last month was 0. These are production apps that we've been running for years and years and paid between $400 and $1,200 a month for per service, per site. And now we pay absolutely nothing for the web server. We still pay for RDS, but we pay absolutely nothing for to serve this Python app. So sort of like a high-level look at serverless architecture. And so this is the 12-factor app really became popular back in 2011, 2012. And it was championed by Heroku at the time, by a guy named Adam Wiggins. And really what it boiled down to was Adam thought that these 12 things would help your site be very scalable, very maintainable. Somebody could jump in easily if you hired a new dev and get up and running. So the first one was one code base, tracked and revision control, mini deploys. Back in 2012, this wasn't always a norm. I came from a job that didn't even track an SVN or Git or anything. But now it's definitely the norm. Explicitly declare and isolate dependencies. This is so important, and I think a lot of people overlook it from time to time, especially people that aren't in a cloud environment now that are moving to a cloud environment. With a cloud, even if you're not going to use AWS Lambda or anything like that, you can still isolate. You can isolate dependencies a whole lot easier. Number 3, store config in the environment. Just means use environment variables and stop using multiple settings files, which I personally have been guilty of. Number 4, treat backend services as attached resources. So you may have a caching server, a database server, an Elasticsearch server, but you should treat those. Your app should not realize that they're not local. Strictly separate build and run stages. Execute the app as one or more stateless processes. Export services via port binding. Scale out via the process model. Maximize robustness with fast startup and graceful shutdown. Keep development, staging, and production as similar as possible. Treat logs and event streams. Treat logs as event streams and run admin management tasks as one-off processes. So Heroku started this theme, or started this mantra, I guess. And then if you went to AWS re:Invent this last year, AWS has sort of taken over this model. And so if you went to re:Invent, you heard 12-factor app after 12-factor app, and a lot of the talks dealing with AWS Lambda or containers or anything else. But why? Well, I'll get to that. I'll try to get to that a little bit later. So you want to run Lambda, but you don't know why. I mean, you don't know how. You don't want to just type some code in the AWS Management Console, or you don't want to use the AWS CLI to manage 50 different functions because it's just not scalable that way. So I've listed out some of the key players in helping you manage your Lambda-based app. Number 1 is Zappa, and we'll get into that one now. Some of the ones that are listed down below are very popular projects, but they're somewhat similar to the ones that I'm listing up here. So going through them and talking about some of the slight differences, I didn't think was a good use of time. So the first one up, which I will talk about at length later, is Zappa. I'm a core committer on Zappa, and we use Zappa at MetaMetrics heavily. So Zappa helps you deploy Python WSGI-based apps. Are there anybody in here? Is there anyone in here that actually works with Python and has to deploy WSGI apps on a regular basis? Joe, thank you. I knew I wasn't alone. And so frameworks like Django, Flask, Pyramid are really easy to deploy with Zappa. Deploying globally is easy with Zappa. And it's not the case, that's not the case with every Lambda framework. From the very beginning, we tried to make SSL very easy out of the box, and cron jobs and building for different stages, whether it's dev, production, or whatever, or a feature branch. And we're currently at about 3,000 stars on GitHub. One of the main reasons I like Zappa from the beginning, as opposed to something like Serverless or Gordon or anything else like Kappa, is that I could get started with a very small config file. You don't need a lot to get started. And if I did not need a domain, if I did not need a domain name for this app, this config file would have been mainly those 2 lines right there. If you're just writing an API, REST API that you want to test, and you don't really need a custom domain name, you only need the first 2 lines. The serverless framework. The serverless framework, as you can imagine, given the name, is by far the biggest player in this space. And here's why. You can deploy multiple languages. It has a very, very large community and VC capital behind it, many plugins. This is one of the things that I've been trying to lobby for in Zappa, is it has a really good plugin system. But one of the things that's you're either for or against is serverless allows the developer to make a crap ton of decisions in the config file. Your config file can be 80 lines long. Sometimes that's good, but if you're on a decent sized team and you have multiple hands in the cookie jar, this can get ugly quick. That's my personal opinion. But if you look at the amount of stars on GitHub, it's definitely the gorilla in the room. So this was the most simple config I was able to churn out with an API gateway backing. So at the top, you'll see that the other thing that I failed to mention is, not other than being language, being able to support multiple languages, it also supports multiple cloud providers. So you can use this with IBM OpenWhisk, you can use this with Azure Functions, you can use this with Google Functions, as well as AWS Lambda. Gordon. Oh, going back to serverless. Serverless works well with, in my personal opinion, it works well with like the Express Node.js framework. It works well with most Node.js frameworks because that's where it got its start at. There's a lot of plugins to make Express and Sales.js and regular Node.js work like you would if you were running it with Nginx or behind Nginx. Gordon. Gordon is the I don't need a framework serverless library, in my opinion. It sort of like serverless, where you see there's a heavy tendency towards JavaScript. With Gordon, there's a heavy favoritism towards Python. But you can run JavaScript and Java as well. Connects, it's really explicit and really easy to connect Lambdas with event sources, whether that event source is S3, an S3 upload if you upload something to a bucket, or a simple notification, or CloudWatch event, or API gateway call, or RDS, whatever. It's very straightforward to connect them with Gordon. So similar to serverless, the config file is once again in YAML, and it's pretty easy to see what's going on. I tell the service, I tell the library up here where my code is, what type of code I'm running, and I tell it down here what event sources to connect it with. So if somebody comes to my API and hits the root URL, I want it to run this function up here. Chalice. So AWS, about 6 months back, I want to say 6 to 8 months back, got into the business of writing Python frameworks. And I'm gonna break out of the mold a little bit. But it is a Python framework, although it's not WSGI. It's not a WSGI framework. Basically what they're doing is mapping events directly either from API gateway, and then it's mapping the URL and the request object from API gateway to a Python function in a similar fashion to Flask. If you've ever written Flask, then it looks pretty much the same as Flask. The only download on this is they make it pretty difficult to serve HTML. It's really geared towards somebody building a REST API, not a full-fledged application. But deploying globally is pretty easy. Cron jobs are easy, and SSL is easy. And it has 2.5, it's almost a little over 2,500 stars on GitHub. So there's some good traction. And if you go to like an AWS Summit or reInvent, if you go to any AWS Summit right now, this is all they talk about when they talk about serverless. That and SAM. So raise of hands, how many people have used CloudFormation in the room? How many people actually like using CloudFormation by hand? No? No, I don't like it, I'm just playing. But SAM makes me actually like using CloudFormation by hand sometimes. Because what they've broken it down to is either using a small amount of JSON or a small amount of YAML to create CloudFormation templates using what AWS calls CloudFormation transforms. And so these small YAML files get really transformed into these gigantic CloudFormation files behind the scenes. And we don't really have to care about it. We just have this 10-line YAML file, which looks a lot like, which ends up looking a lot like this. So really all it's saying here is, hey, I have this function. It's a Node.js function. Here's the function I want, the actual function that I want to handle. And hey, my zip file for this code is on S3. You take that to the the CloudFormation console, put it in, and it just runs. If I can get down to the, yeah. So here I was saying, in this template, I should probably scroll up a little bit so you can see. So in this one, I was basically saying, hey, I have this template here, this file here, and then I wanted to run this this handler, and then it just works. It creates everything like you would normally see they create in CloudFormation. And so that's the end of my overview. Now let's get into how we at MetaMetrics deploy WSGI apps. So WSGI is basically Python's way of deploying and serving web apps or HTTP-based apps. So let's go ahead and get started. So I'm going to go through like some of the AWS steps that we take, and I'm going to sort of go through some of the commands and code for the local environment, and then I'll go through like the Zappa steps, and then I'll go through the CloudFront steps, which is sort of like the optional stuff, but this is what I like to do. So I'm gonna tell you about it. So these are only the steps, but I think you should, if you want to go down this path, you should write a CloudFormation template that helps you automate some of these tasks for future deployments. So first, you want to create 4 buckets. We used to create 2 buckets, but then AWS Apocalypse happened, and we realized that we probably shouldn't just have our stuff in US East. So we create 2 buckets. We create 4 buckets now, 2 buckets in each region for our code that zip file to be uploaded to, and then another bucket in each region for our static assets to be uploaded to. So like for us, a lot of times we build web applications, so we want to upload like our CSS, images, JavaScript, stuff like that, so we can serve it later on with CloudFront. So you want to configure your VPC. How many people in here similar? I'm expecting I'm going to get a similar answer to the CloudFormation answer, but how many people in here like configuring VPC on AWS or have done it? How did you like your experience?
Well, the GUI never worked for me. I finally broke down and wrote it up in Ansible.
Yeah, we've had bouts with VPC, but in the end, it's worth it because we need to be able to allow Lambda to talk to our RDS instances and Elastic Cache instances without having the threat of those instances being able to be directly talked to from the internet. So first, we want to create public and private subnets. You want to create at least 2 in different availability zones. Possibly want to create them in, probably want to create more than 2. But at a bare minimum, create 2. And then you also want to create a NAT gateway. The NAT gateway enables your Lambda functions in a private subnet to connect to the internet or other AWS resources. But it also blocks internet from initiating a connection with those instances. So you want to associate your NAT gateway with one of your private subnets. And this is needed if you're planning on using any public API other than S3. S3 has its own what's called the VPC endpoint. They're supposed to be adding more services, but I don't think they have yet. But if you want to connect to stuff like MailChimp and Twilio, definitely do this, because your Lambdas won't work, and you'll be wondering like why, and you won't get any good error messages. So you want to create a route table, and this sort of just controls the routing for your subnets. It's not much more other than that. And then next, like I said earlier, just to be on the safe side, you want to create a VPC endpoint for S3. So we like to use Django, but any library that you want to like upload your S3 and your stuff to S3, and that when you need it to talk to certain things, especially if you want to run the upload of assets within Lambda, this is a good thing to do. So next, you want to create a custom IAM policy. We're using Zappa to do this, and Zappa's default policy is way too loose. So you pretty much have godlike account privileges if you use default. So make sure that once you're setting this up, you go through with a fine-tooth comb and just see what exactly you need to set up, or your Lambda needs access to. And then create an RDS instance. If your application needs some type of relational database, create an RDS instance and associate it with the VPC and subnets you created in the previous steps. If you're using Redis or Memcached, now is the time to go ahead and create that Elasticache cluster and associate it with a VPC and subnet. Associate it with the VPC and subnets that you created in step 2. Y'all still there? Just about? All right. A lot of these steps are sort of language agnostic, but here, like that we've already talked about. But here's where we're going to get into like a lot of the Python stuff. So I like to do this mainly because of earlier we talked about using environment variables in your settings files, in your config files, to lower the risk of things getting in GitHub, or security credentials getting in GitHub, or just different people on the team having different credentials. I like to use environment variables, and I like to use this project called Eva, which as soon as if you've ever worked with virtual environments, if you create the virtual environment with the project folder, as soon as you switch to that virtual environment, it pulls environment variables from a .m file and populates it in that virtual environment. So, and then the next, in order to deploy this Django app, we'll need to pip install Zappa, another project called EMS, which allows us to easily pull in environment variables in a cool way and respect Python types of objects. Like, it's pretty hard to sometimes pull in lists or tuples or sets, and this project makes it easy to do that. Of course, we'll need Django, we'll need MySQL, Python. I like to use Django storages and Bodo and Django Redis. So, like we would do with a normal Django app, we would create the project by running Django admin, start project, and then we'll just call the project name your blog. And then we'd set up our settings file with all of the environment variables that we need. And then we would create a custom storage backend to store everything in S3. And then with Zappa, we would run this command called Zappa init, and it would go through all these lists of questions about what S3 bucket do you want to publish your code to. And if you don't have a bucket, it'll create one for you. Then it'll ask you if you want to deploy the app globally or you just want to deploy it to the default region for your AWS credentials. And then it'll also ask you where your handler is, where your WSGI app handler is. But there's defaults for that. It's pretty good about detecting whether it's a Django app or a Flask app or any type of WSGI app. And so here's how we're doing our here's that same Zappa setting file from earlier, but now we have a dev stage and a prod stage. And we're telling it which regions we want. We're telling it where the S3 bucket is that we want, like we did before. But now we have all of these other fields. And so you can use your Let's Encrypt key with it, or you can use, as of I think about 2 weeks ago, we released a function where you can use their ACM certificates now. ACM is Amazon Certificate Manager that gives you free SSL certs. It allows you to, it's pretty cool because it gives you free certs, but not just regular certs. You can get free wildcard certs as well. So it's just pretty cool. And you can set the domain like we did before. And then you just run Zappa deploy dev, and it will create these CloudFormation resources for you, and deploy and create the API gateway for you, upload your code to S3, and create the Lambda function for you. And then it'll spit back out in the API gateway URL. And you'll be able to run, and you'll be able to look at it, and it'll just work. But if you need to do migrations, like with a normal Django project, we have these Django-specific commands under Zappa manage. And Zappa manage will just allow you to migrate like you were in a regular Django project.
Right.
Yes, sir.
Are those run as Lambda functions, or are they?
Mm-hmm. Yeah, it runs the manage command inside the Lambda function on AWS, not locally. So if you don't have access to the RDS instance because of VPC, you'll have it, you'll be able to run it because the Lambda will have
So
VPC
does it
access.
set up a one-off Lambda function?
No, no. There's a in the Zappa handler, it understands that you're calling the overall handler.
What's the communication?
It's just using Bodo to call it. Yeah.
So it's Bodo through the Amazon API, not through some kind of web service that it uses.
Yeah. And you would run, so earlier I talked about creating a free SSL cert and tying it to your API gateway and creating the Route 53 records to tie it all together. This command, Zappa certified dev, does just that. So if you've decided that you wanted to use Let's Encrypt, it will take your Let's Encrypt key and bring in that certificate to API gateway and serve your site with SSL using that cert, or it will take your a certificate ARN, or Amazon resource number, I guess is what the N stands for, and take that SSL cert and pull it in and secure it that way.
Brian, you have a question?
Oh, sorry.
For the certified command for Let's Encrypt, does that automatically renew the certificates as well?
Yes, through a CloudWatch event. So if you're not familiar with Lambda that much, you can use CloudWatch events sort of like cron jobs. And so through those CloudWatch events, every 30 days it goes and updates the Let's Encrypt. Yes, sir. Good question. Similar to before, with the migrate, you can run Zappa manage collect static. I don't know if there's any Django developers in here or anybody that has a lot of files that you need to upload to S3 at one time. It can take about, depending on how big your files are, like 10 to 15 minutes to upload all these files, especially if you have a big app. But it takes less than like 45 seconds on some of our bigger apps to upload it from the Zappa manage collect static, because it's uploading from Lambda, which is technically like EC2 to S3, and the distance is so short and the connection is so great that it's up there in an instant. So here's where I go off the beaten path a little bit, and I use Amazon CloudFront. I like to use Amazon CloudFront as a sort of like a HTTP caching service instead of just as most people think of CloudFront. They use it to speed up the delivery of their JavaScript files or their CSS files or their image files. Well, I like to speed up the whole site. And this helped us out when Apocalypse happened, because it was 2 to 3 hours before we even noticed things, well, before everybody outside of engineering noticed it. We noticed it right away, but because CloudFront is caching certain areas of the app, like the home page or things that don't change that much. And the cool thing about CloudFront, and I'll show you in a second, is that you can set up these different behaviors based on the path and caching mechanisms. So So over here for my blog, how many people have used CloudFront at all? Okay, 2, 3, 4. All right, so the first origin is my blog. The second 2 origins are S3 buckets. And I have them set up to where they look like they're on the same URL. So when you go to the site, I'm telling root, and I'm telling the default behavior to serve from Lambda. And I'm telling home to serve from Lambda, but I'm giving it very high TTLs, because this stuff on the home page shouldn't change that often. But things underneath the Jinwright prod media and Jinwright prod static folders, I can give extra high TTLs, because those are static URLs, and I'm using a query string to invalidate those when new ones come anyway. So I can give that a 30-day TTL, so it never hits S3. So it's always fast, no matter where you're coming from. And things like the admin, like /admin, I give 0 TTLs, because I want that always to be fresh. I want it to always round trip to Lambda. And so doing this, I was able to move my requests per second in load testing from, I think, 1,700 requests per second to over 30,000 requests per second, with not a lot of overhead. I only pay at this point when people come to the site, and that's where I want to be, to get that type of performance. And 30,000 is just where CloudFront started thinking, okay, this might be a DOS attack. Let me shut down some of these requests, because it was all coming from the same general vicinity. I mean, the same IP. And that's mainly it. Is there any questions? Yes.
You mentioned DDoS attacks, things like that. Do you use the web application firewall they have?
Yeah, we've used it briefly.
Brian, can you repeat the question for everyone?
Yeah. Oh, yeah. So he asked if we use AWS WAF, or AWS Web Application Firewall, and we have, but not to an extent I feel like I could give expert knowledge on it. But was there a particular question about it?
Just in terms of, you mentioned certain attack vectors that use the firewall and apps.
Yeah. So in terms of using the firewall, we've only used it to block out certain regions of IPs. That's mainly the extent of what we used it for. Oh, I think Joe was there.
Does the Lambda function shut down when it's not in use?
Mm-hmm.
What kind of processor state is kept?
So it's held in, the process is held in cache if it's hot. So if you don't use it, I think App Engine used to do something similar to this too. Like you'll have a cold startup time. But what we've done with Zappa is allow you to keep it hot using CloudWatch cron jobs. So every 10 minutes every 5 minutes it'll make a request to keep it hot and keep it in
Yeah, 'cause I'm worried about,
cache.
like if it was starting up a whole whiskey stack per request, that would be
Yeah.
a terrible performance.
Yeah, but no, to keep it in to keep it in cache or to keep it live or hot, there's ways around it, especially specifically using CloudWatch events. I think he was next.
You were talking about VPC and Lambda functions, and said something that I didn't understand, which was in order to access public RESTful APIs, you need to set up a VPC. Can you elaborate more on that answer? Because
Yeah.
it seems contradictory. It seems like
I'm glad you asked that. To clarify, if you deploy your Lambda within a VPC that doesn't have rules if you deploy it within a VPC, you're going to need to set up.
you need to be configured if you're deployed within a managed environment, in other words.
Yeah.
Because maybe you have some inbound traffic that would be routed out by the VPC.
Mhm.
So you mentioned some of these frameworks that you use, Zappa and Serverless, and how they tie into AWS Lambda. Do they also provide options for alternatives like rules, etc., or is that not even worth mentioning?
Serverless does. Serverless, I think I mentioned it earlier, but serverless you can use with IBM's OpenWhisk. You can use with Azure Functions. You can use with Google Functions, and with AWS Lambda. We're close to Azure Functions with Zappa, but not yet.
Have you ever used Lambda to augment an existing app? What were the challenges with that? Like you say, you want to, on your host, have performance for a particular parallelization, or you have some function you want to turn to a Lambda, but you've got your core app. Have you ever tried to run both at the same time to service the same?
We're in that process now. In some ways, like a lot of this stuff right here, we just took existing apps and took them out of EC2 and put them in Lambda. But for a lot of like our REST services, and things that we would normally use Celery for, is what we're taking out now. I was looking that way. I didn't know who's next.
So I was just at an Azure Serverless presentation the other evening, and they were talking about the monetization being strictly fractions of a CPU second.
Mhm.
And I know AWS has something called a gigabyte hour, and there's sensitivity to the size of the footprint that you fit in. And so depending on how big your Lambda function is or what additional libraries you need, you might need a larger footprint, and that would change your divisor on how you get billed. Can you speak to the billing on Lambda functions?
Yeah. So it is tricky because the only unit of deciding whether you get more power is deciding how much memory you have, and that sort of behind the scenes determines how much CPU you're allotted, everything. And so there's sort of a guessing game of would this be better as a 128 megabyte instance and be using step functions to run these things in parallel, or is this better for me to use 1024 and just knock this all out in one? Luckily we haven't run into a problem of where we've had to pay yet, because they give you like 1 million requests a month, pretty much for free. So think.
Well, I guess you kind of addressed that, and then you get so many requests for free, but if you have to keep these lambdas hot periodically, eventually it seems like you might start building costs. Would you ever get close to what you then would spend on VPC, or I mean on a dedicated EC2 instance? If you're wanting a fast response time, and I guess if you're not using their free tier, what is that trade-off now? Keeping it.
Well, I think you always have the free tier, so you're always going to get those million a month, depending. And the million, I should say this: the million is based on is based on the gigabytes per hour, like you said. So, like, if you're running 128, you'll get more requests for free than if you're running 1024.
Okay.
But if you're if your utilization is every second of 720 hours a month, then you may be better off going with EC2.
Which is not the case that most people are in. So.
Yeah,
Not yet.
yeah. It's not the case that most people and even still, you still have a trade-off of, do I want to manage EC2 and add the complexity of running something like Ansible and Puppet or Chef, or and do I really want to do OS updates and
So you actually feel that this, on that note, the next question, and I'll be quiet, but this appears to me to be more complicated than keeping an EC2 instance going, probably because I'm familiar with the latter, but you feel that this is simpler.
I think, yeah, once you it's like anything. Once you have dug in and gotten to the point of you're comfortable with the terminology, you're comfortable with what needs to go where in config files, and you've done it a time or two. Coming from somebody who, at my previous job, did a lot of Ansible stuff, I think this is simpler, because I don't have to. As long as I'll put it to you like this: as long as I deploy all of my lambdas globally, which is free to do. If US East goes down, I don't care, because US West is still up probably. Europe is still up. And that would be the case. That could be the case with EC2. I mean, Netflix is doing that. Discuss is doing that. Everybody, a lot of people are doing that these days, but I think it's harder to do. And it's definitely more expensive to do.
So you consider this more globally resilient downtime?
Joe.
What's the upgrade scenario? Is there a zero downtime upgrade to a Lambda function?
Yeah.
So it's like a blue-green style?
Yeah. So if I push update, the cool thing about Lambda, and I'll answer this in two ways, is it's very easy to do stages. It's very easy to do stages for like feature branches. And so I know that this is going to work. And so once I flip the switch, it's not going to be like with EC2 if you don't have your things baked and you're waiting for ELB or Elastic Load Balancer to point to this new stack of servers. No, it's instant. As soon as you hit that deploy and you go and look at API Gateway, it's there. You're not worrying about status checks and things like that. It's just there.
The gotchas in the beginning, and I'm just curious, like, so if you have a developer who's been, not worrying about the deployments or anything, but now you're throwing Lambda in the mix, what are some ways that they can shoot themselves in the foot or mess things up? Is there any gotcha there?
I can tell you some of the ways I have. NumPy and SciPy, you have to treat them as, because you only get a 50 megabit limit, right? And so those are big libraries. And so if you have big libraries, you definitely, Lambda is definitely geared towards people making the move from monoliths to microservices. So you should definitely try to break those up into really small, just functions at that point. Not try to have a handler in front of it and then have like 4 or 5 classes that you're routing things to. If it's a big library and it's gonna cause a lot of problems and break them up. Other thing is language version numbers. At MetaMetrics, before we started moving things to Lambda, we made the switch from Python 2 to Python 3. Well, Python 3 isn't out for Lambda yet. It only supports Python 2.7. And the same until last week was the case for Node.js, but they just got I think it was last week or week before last, they got a version upgrade. So you have to realize what you're building for, so you don't run into a brick wall there. Some other gotchas, it's very easy to do things using things like Bodo or other SDKs and just say, hey, I'm just going to put this Lambda up and I'm going to bypass CloudFormation. If you're using Python, use Troposphere. I think Ruby has its own language, its own project for CloudFormation. Use CloudFormation because it's easy to take the whole stack down. And it's easy it's just good housekeeping, I guess, is what I'm trying to say. It allows you to see where the money is going, especially if you're utilizing tagging. So those are the main gotchas. Other little things are, if the process is going to run over 5 minutes, Lambda isn't for you, or you need to break things up.
There's, in addition to serverless, there's the paradigm of real-time apps.
Mm-hmm.
Am I correct in saying the two are kind of mutually exclusive, or I guess, what's your take on that? If I'm trying to build a real-time app, can I use serverless, or is it just better to go EC2?
Depends on your performance needs. Kinesis has a. Is that better? Oh, okay. So he was asking if you're planning on doing a real-time app, is Lambda a good fit? Probably to start, it is. Using Kinesis and Lambda is probably a good start. I think you're probably going to run into a situation where after about the first 50,000 users, you'll probably say, hey, I want to move to EC2. But at that point, you vetted the app, so it's worth it to go to EC2.
Okay,
Yes, sir.
so you mentioned the monolithic apps. You were probably talking about web apps, but there's monolithic workstation apps too that are now being moved into the cloud, and a lot of them have headaches with that. And part of the problem is that there's certain pieces of the compute job that are just way more efficient to run locally, like on a graphics card. And if you move the app wholesale into the cloud, then you have this huge bandwidth problem trying to move all that graphics data. So is there a way to only go partly serverless?
Yeah. That for your use case, I would say like there's probably some part of that app that is very CPU intensive that doesn't have to be done in real time, right? That you could somehow move some part of like some type of metadata and then some large batch of the job to the cloud in the end. I think that's probably where you should focus at, not on every insert or every IO that you're making. More so like, what does the end result look like, and can I move?
Well, it's like with parallel processors.
Yeah.
Which parts of your job can be parallelized? And, maybe you put those in the cloud.
Exactly.
Is that what you mean?
Yeah.
Amazon does have graphics card instances.
Yeah.
Well, yeah, but I mean, the people who are interested in this sort of app tend to already have $3,000 graphics cards, and they don't want to pay Amazon to duplicate that.
Sounds like a poor choice for cloud.
Yeah, but some of the people that are running the software of interest, these monolithic apps, are being forced into these cloudized apps.
It's definitely a new area for me. Is there any more questions? That was a good one, though. Say that again?
Change for the sake of change.
Oh, yeah. That is true.
Well, actually, it's to force people that have perpetual licenses for things like 3D Studio Max
Oh,
to
to
go
move.
into software as a service and pay for it every month.
Yeah. Yeah, that's a whole debate in itself.
Yeah.
All right. Well, thank you guys. Appreciate you having me.